Hello Java students. So we are going to finish up the infection game right now in our code. So I've got our pseudocode document pulled up and I've got a partially completed IntelliJ code written here. As of right now, this code has the move method as we wanted it to. It's got an infect method. To do an infect here, what I'm going to do is I was looping over that 3x3 grid that is around the surrounding piece. In order to do that, we want to go up one row and up one column and continue looping over the rows and columns until we are one below in the sense of row and column. Sorry, I confused myself a little bit pausing to look at that. From my top row, I want to go 2 down, or from the initial row, I want to go 1 above the row that I'm on and then the row below. So however you're choosing to write that is totally fine, but that infect method should loop over the 3x3 array. The one thing we really do need to be careful of is that we check that each of those positions exist within the grid. Remember, if your target location is on an edge or a corner, you're not going to have all 8 neighboring or all 8 first perimeter pieces, which means that you need to check that it's within the grid first before you do a check to make sure that it's belongs to the other player, which means it's not empty and not the current players. And if all of those conditions are true, it's within the grid and it's a piece that belongs to the other player, well, that's when we infect and make it our piece. Okay, from there, what we added on today was this game over method. So part of what's written in the pseudocode now is, in the code now, is direct translation from the pseudocode. The board being full seemed like a very short piece of pseudocode, so I went ahead and translated that into IntelliJ in Java. And the same is true for the current player having no pieces. Both of those are about 3 lines, and in fact, you could probably stick those two together and have it be the count of 0 equals 0 or the count of current player equals 0. Then we should return true that the game is in fact over. In order to have both of these methods, both of these checks, it required us to have a count method. So the next thing that I went through and did was write up quickly our count method. What this method was supposed to do was create a counter variable. Then it's looping over all of the positions within our 2-dimensional array. If a given position within the grid is equal to whatever the value is that's the input of that method, we're going to increment that counter. Once we've looped over all of the positions, we're done with both of our for loops, then we're going to return that value of how many times we counted. We're going to return the counter, which tells us how many times we counted a given value within the grid. So that's helpful to tell us if we find that the count of 0, meaning the count of empty is 0, meaning there are no empty pieces, then the board is full, so we should return true that the game is over. Or if there are the count of the current player, meaning if you're player 1, the count of player 1's pieces is equal to 0. Player 1 has no pieces to move, therefore, how can they take a turn? And we should return true because the game is in fact over. The third situation that we want to consider here is the current player has no valid moves. And while the pseudocode itself is only, 5 lines long, it's actually a lot more in depth than that to do the check for checking for valid moves. What we want to do is we want to check every current player's piece. Now, I know that there is a current player piece to even check because in order to get to this line 81, we had to have already passed this situation. We aren't at a case of no current player pieces if we're on line 81. So there's at least one piece for the current player on the board, so we need to go check it. And in fact, we don't know how many there are, so we need to go check all of them. So what I want to do is I want to loop over my grid, and all I'm doing right now is looping over the entirety of this 2-dimensional array, looking for any piece that belongs to the current player. So this is looping over the entirety of the grid, and then what we're doing is we're checking to see if the grid location is equal to the current player. So grid of RC in this case, if that's equal to the current player, because then we found a current player's piece. So all of this is doing the for every current player piece on the grid line that's there. So if we find a piece that belongs to the current player, then what we're going to do is we need to check to see if there's an empty space within the first or the second perimeter of the current player. So in order to do that, we're going to treat this case very similarly to how we did with the infect method. I've found a piece that belongs to the current player. What I need to do now is go check the 8 pieces that would be in my first perimeter and see if any of those are empty. If so, then that piece has a clone move available to it. Then if not, then we'll keep looking. Then I'm going to go check those second perimeter pieces. If there's one of those that are empty, then that piece has a jump move available to it. If not, then that piece at the moment has no valid moves available to it. And that's kind of the same logic that I used when I made my AI to play computer, to have the person play against the computer. Now, like we talked about when we were trying to figure out how to write that infect method, we don't have a way to walk the perimeter of our arrays. We can't say go around in a circle like we want to, but we can loop over smaller grids. So instead of considering, it's pretty much the same as infect, instead of considering it as walk those 8 pieces and walk the other 8 and 3 and 3, 8, 12, nope, 8, 16, and an extra 22. Instead of walking those 8 pieces and then those 22 pieces of the second perimeter, let's treat all of those pieces as the 4x4 grid that's around my center location. So in order to do that, I'm going to loop over all possible values that would be within the first or second perimeter, and I'm going to do that using a mini 2-dimensional array inside of our grid. This time, however, unlike infect, where I had to go 1 back in the row and column and then end up 1 below in the row and column, this time I need to go 2 back for my rows and 2 back for my columns when I start. So I'm going to create a new integer that I'm going to call perimeter R, because that'll be the perimeter row that I'm walking. And it's going to start equal to the row of the current player's piece minus 2 to start 2 above. And it's going to go until that perimeter R value is greater than the R value plus 2. So we want to keep going while the perimeter piece is less than or equal to that row plus 2, because we can go 2 rows below. And each time as we increment, we're going to increment that perimeter. So remember, this is allowing us to go from the 2 rows above the current player's piece all the way down through the 2 rows that are below the current player's piece. So it'll check above, the row where the current player is, below, to check all of the surrounding possible moves for that current player's piece. Then I want to do the same thing. Oops, I'm typing random things in the column direction. So I'm going to create an integer that I'm going to call perimeter column, and it's going to be equal to the current player's column, which is C, minus 2. And we're going to keep going again until that perimeter C is greater than C plus 2. So opposite for when we're setting that condition. And then we're going to increment it as we loop. So now this is doing the part of checking for an empty space within that first or second perimeter. So I'm looping over the first or second perimeter. What I want to do is I want to check and see if the grid at my perimeter row, perimeter column is empty. Because if it is, that means there is a valid move for that current player to make. And so we can return false in this method. We have found a current player's piece that has a valid move. So therefore the game isn't over yet for this condition. The player does in fact have a valid move still. Now, in order to be able to even check the grid position of our C, we have to do a little bit more work and be careful because there aren't many pieces actually, even in our board, that have a full 2 perimeters all within the board as well. So before we check grid of that perimeter row, perimeter column, we first have to check that perimeter row and perimeter column are in the grid. So we're going to say if is in grid of that perimeter row, perimeter column. Make sure it's a value within the grid first. And then if it's empty, we can return false. And this is going to prevent that array index out of bounds error that you will often see. Because if we don't check this, and let's say we clicked on a corner piece, there is no 2 rows up or 2 columns over from a corner piece. And so this is then going to tell us, return false, we found a current player's piece and we found that it has a valid move. Now we're not telling the player what valid move it is. This isn't the AI necessarily, but it's telling us that there is a valid move to be found. However, if we get through looping over the entire second perimeter and first perimeter for that current piece, and we don't find anything, and we don't return false, then that means that that current player's piece, that specific piece, doesn't have a valid move. Now, one piece not having a valid move should not end the game. We need to make sure that we found all of the pieces and that none of them have a valid move. But if we get through looping over the entire 2-dimensional array, for every current player piece that we find, we don't get into this if block, meaning we don't actually return false. We finish all of the for loops. We finished looping. Current player never found a valid move, then we should return true. So outside all of the for loops, but still inside of my is game over method, my failsafe switch is return true. The game is in fact over. You didn't find a case of a move to be made, therefore there must not be a move to make. And now my is game over method is exactly as I want it to be. Okay, this is getting long, so let me wrap up from here. Now that we have this is game over method, the last thing is actually calling that is game over method, because right now nothing gets displayed. So the one check that we need to do is in our run graphical game class, inside of this draw method, we need to actually check that is game over. So in order to do that, let me scroll down so we can see what I'm looking for in my pseudocode. If game over, but what I really mean by that is game dot is game over. And I can put equal equals true, but you have also caught on to the fact that we don't have to do that. So I can write equals true or not, because this, remember, returns true or false. So we're basically saying if true or if false. So if the game is in fact over, then we want to display some text. Now remember, in graphics, we put the message of the text. Then we also have to separate it with a comma and put an X value and a Y value. So I'm going to put, so let's see, 450 might be over to the right enough. And then let's do 250. And I'm just making a guess right now of where that should go on the screen. So that's going to tell me that the game's over. But remember, we also decided that we want to decide who wins this game. So then what we should do is we should say if, and now we need to get the game's method called count of 1. If that value is greater than the game's method count of 2, that means that player 1 should win. So then we're going to put more text. And I'll put that in the same X position, but slightly further down. So let's put it at 300. And then if I get into the else block, then that means, well, I'm going to copy and paste. But I'm going to change the word to say player 2 wins. And I can put those at the exact same location because only one of them is going to get displayed at a time. Okay, so now let's just run it, test it out really quickly, make sure it's doing all of the things that we want it to do. I'm going to play as kind of a silly user so that we can win this game quickly. So player 1 is the red player is going to do the smart things. Player 2, the green player, is going to do the not smart things. Okay, we're close to getting there. Jump. Where can I jump that I'm still in range? Good, cool. Got there. Okay, and so now I've done that. I see a game over message, and it also tells me which player wins. Right now, that text is going to show up in the color of whatever piece just moved last to cause that game to end, so it's likely that player's piece. I can change the text. I can change the text color if I want to. All of those aesthetics are up to you if you would like to do so. But that is it for your infection game.